My name is Richard Lagerveld. I'm the program UG coordinator of the CBE department. And it's my pleasure to introduce to you the programs that we have in chemical and biological engineering. After that, my colleague, Professor Frank Lamb, will take over and tell you something about the sustainable energy program, or SUSEE, as we like to call it. But first, I will introduce our CBE programs. Let me start with the big elephant in the room, right? So what is actually chemical and biological engineering, right? Before we're talking about any programs. There are different ways you can look at it, right? So one way to understand what is chemical engineering is by looking at this, right? So we are part of school engineering. Take, for example, water, right? So I think for all the departments, water for engineers is just wet, right? I guess for you it's also wet. For me it's also, but for chemical engineers it's more than just wet. So we see the molecules that behind the material, so we think in molecular interactions, hydrogen bonding. So chemical engineers really have that view to try to design new processes and products by thinking at the molecular level, right? So chemistry obviously is important here, but we are not chemists, right? So we apply chemistry to solve problems that are very urgent, for example, healthcare, energy, and environmental aspects. Right, so I already mentioned processes and products. So this is another way to look at chemical engineers, right? So chemical engineers have actually a very straightforward mindset, right? So a chemical engineer often thinks like this, especially those that work in the industry. So they think, okay, what kind of products does the society need that have a high value? And how can I make those from raw materials that are cheap and abundant to get? Or maybe these raw materials are even waste products, right, that people want to get rid of. We can get them for free, or people pay us, and then we try to convert it into products, right? So this is really the core essence of one part of chemical engineering, is to design processes that convert raw materials to physical, chemical, and biological transformations into valuable products that you and I need every day. Right? So for example, in food industry, pharmaceutical industry, consumer electronics, polymers, energy, etc. And these processes can be very big, like we have, for example, in Hong Kong, town gas, CO2, but they can also be very small. Right? So in this room, fortunately, we have air conditioning, right? And air conditioner is also something that enables a process, right, from hot, humid air to dry and cool. Think about air filtration units, all of those things are processes. So processes can be very small, can be very large, but in chemical engineering, you learn the underlying principles to design and analyze what we call process. But chemical engineering is not only about process, it's also about the product. So we try to design products that are needed by society, that one can earn money with, by designing the product. Right? So product design is another important aspect. Okay, so that's the second way to look at chemical engineering. And then the third way, well, maybe let us just look at some examples of research that is ongoing in our department. And you may recognize some actually from newspapers. Anyone knows this? Magic? Anyone? No, it's very small, so you may not have seen it, right? But this is what helped us to keep safe during the pandemic, right? So if you go into the buildings and you push on the lift buttons, right? So sometimes you see these buttons have been sprayed with a special coating. Very often that coating is actually from our department. So it's Professor Kimberly teams who developed that. Actually already before the pandemic, but obviously became very important during pandemic. So what they designed is a nanofibrous material. So it's a material that consists of very small fibers that can kill germs, right? So this is another typical example of chemical engineering, right? So a chemical engineer needs to understand how to design a material, how you should make sure that it actually works, but also a process to manufacture it, right? So you can see here that actually this won many awards in Hong Kong. They scaled it up, it's now a company, and they also need to produce this on large scale, right? So to design the product and to design the process. Another example is in 2D materials. So this is from my colleague, Professor Tom Lowe. So basically, 2D materials are very special materials. So these are materials that are so thin that the thickness is only one atom. Incredibly thin, right? Impossible to see, obviously. Very, very thin. So graphene is the most common example, right? Won Nobel Prize. The chemical engineer, they basically try to understand that material and then solve problems with it, right? Engineering problems. So for example, problems in healthcare, so they developed a certain type of particle that can filter blood from patients that have kidney failure, so they can filter the blood with this material. They designed a new type of battery, right? So lithium-ion battery is not a common battery. They used this technology to design a new type of battery that has 3 times higher energy density based on silver. Another example is in biosensors. So this is very conductive, so you can actually make electronics from it, and then you can make sensors that you can use for biological tissue. Right, so this is another typical example of chemical engineering. So, right, so we take the understanding on the molecular level, and then we solve big problems in healthcare, energy, etc. Okay, so that is chemical engineering. It's a very broad discipline, but I hope you have at least sort of a flavor of what it means. Then how about biological engineering, right? So biological engineering, obviously closely related to chemical engineering. Actually, processes can be biologically oriented, right, like fermentation. But another way to see biological engineering is that it actually bridges the life sciences with the engineering, right? So life scientist typically seeks to understand, the engineer seeks to apply, right, to solve problems, and biological engineering is really on that interface, right? So it really bridges life sciences with the engineering discipline, right? So that's why we are in the School of Engineering. So what does it actually mean? Again, perhaps best illustrated with some examples from our department. So this is work from my colleague, Professor BEng, who actually developed biosensors, sweat sensors. So you can see it's kind of like a patch. You put it on your arm, and then it's a very ingenious device that can process your sweat and then can measure biological things like glucose concentration, salt concentration, so you can actually get information about your health status, right? So this is being used by athletes, for example, but as you can imagine, it also can be very important for remote monitoring of health, for example, for the elderly, or early intervention if people suffer from certain diseases, right? So again, you use principles from life sciences because these are patches on humans, but as a real engineer, you need to design, you need to optimize these kind of devices. Okay, another example for my colleague, Professor Ying Chao, right? So we all heard that mRNA won the Nobel Prize. Actually, we're also working on mRNA. It has a lot of potential. And there are many aspects to make medicine or therapies from mRNA, right? So I guess quite some of us may have used the mRNA-based COVID vaccine. So mRNA is, of course, known from life sciences. It's known what it does. It can transcribe proteins that then can give messages to your body, for example, to produce antibodies. But that alone is not enough to turn mRNA into a vaccine, right? So we also need good biological engineering, right? So, for example, what she works on is she creates nanoparticles to deliver the mRNA efficiently into the cell, right? Because if you just inject mRNA, nothing will happen, right? So you need to make sure that the mRNA gets delivered into the cells, right? So they create a very small particle through something called self-assembly. It's a spontaneous process. It's kind of like a vehicle. The target is the mRNA. It ships it into your cells and then it releases that to produce proteins. mRNA itself is very interesting, so we have more colleagues working on that. So there's also an example of what's called synthetic biology. So in synthetic biology, you use the power of nature to create materials. So for example, my colleague, Professor Becky Duan, she actually designs these kind of mRNA molecules, right? So not natural ones, so they're synthetic, but she designs them in such a way that they're very effective. So again, biological engineering is very broad. We don't have time to discuss all the aspects, but I hope that these 3 examples of ongoing research in our department give you an idea of what it is. Okay, so enough about our discipline and research subjects. So let us look at students, right? So that's why we are here, of course. I think you are happy to know that these are very important research areas, right? So they deal with energy, healthcare, all very big problems that we deal with nowadays. And we try to engage our students in that kind of research as much as possible, right? So of course we facilitate university-wide research projects, but we also have our own research course, so you can join a lab, and for example, you can make a sweat sensor and you can try to optimize it. In your final year, you can do a research thesis where you go into more depth to study some of these things. So we are proud that we heavily engage students into our research, right? We think it's a very meaningful experience if you want to do that, right? Also, we have agreements with overseas institutes, so some of our students also, they do this, but in a different institute, right? So we try to use our connections to send our students to different universities. For example, we have an agreement with Georgia Tech in the US, and then our students can go there and do a research project there. So we're very proud of that, and all of that leads to quite some student-led innovations. Actually, a lot of these things come from courses, so our courses often have projects, and then we need to design something. So design is a typical engineering skill. So this is a nice example that was actually a student project in a product design course. So they designed, this was during the COVID period, a hand cream that had antimicrobial properties. And they did not only design that in the course, right, to pass the course, but they actually spin it off into a company. They got help from one of our alumni who know the cosmetic industry well. And then actually they create a commercial product out of the student project, right? So it's very nice. We are very successful. We are very proud of that. And this is another example of a final year project. So this we call the Smart Fish, supervised by Professor Frank Lamb. So this is about microplastics, right? So big environmental problem. You may know there are many plastics in the oceans, and that is a problem. So this is an autonomous robotic system that can detect and count the microplastics in the sea. So it can help to map where those plastics are. And well, we cannot go into all of the details, but if you look at how ingenious this is built, different aspects, right? So it's electronics, it's water treatment, it's control, it's imaging, image analysis, chemistry. So this is real teamwork. This is not one student that does that. These are different students, sometimes from different departments actually, that work together, put their creativity together, and to design these kind of things, right? And we're very proud that actually they won external prizes from that, from Hong Kong Institute of Engineers. Okay, this is a Chemi car. I have a very nice movie. It's a little bit a funny one, so don't be scared. But this is actually a competition that we send our students every year to in the United States to design a car that is driven by chemical reaction and then needs to go a certain way. So this video actually won an award. So let's have a look. There it is. Battery for it, and they make it themselves. That's the battery. So they need some way to stop it. So every competition they tell them how far it should drive, and they cannot use brakes, so they need some stopping mechanism through chemistry. They use 3D printing, so if you have a chance to follow a lab tour, you can see this is our experiential learning lab. You can use 3D printing. Okay, it's not wonderful, right? Actually, they won an award with it. It's not only us who like it. So next month we again send a team to Orlando in Florida to participate in this competition. So if you have a chance, you can actually see it. You can ask them, are we going to Orlando next month? So they will be surprised, you know that. It's in the experiential lab tour that we have today. So you can go have a look at the card for this year's competition. Okay. So we also, our students, again, through all their creativity, they have won several internal awards. So we have been very successful in HKUST President's Cup, which is the most prestigious internal competition for student projects. So we have, our students have won a prize for autonomous water purification system. So what that system does is, if you think about a household and you have a laundry machine or dishwasher, it produces water that now goes into the sink. Imagine if we could clean it up and then recycle and then reuse it. Okay, so the students took that idea and they built their own device that can actually do that. So you can bring it to a dormitory here, for example, on campus, to recycle water and in this way save water. And they collaborated, I believe, with ECE department, so they also have a mobile app, so you can control the whole thing from your mobile phone. This is again a spot sensor type of material, so from polymers to detect fatigue for athletes. The smart fish, you've seen that, also university won a prize, right? So if you can think it as a student, you can do it, right? So we provide the facilities, the supervision in order to make your dream a reality. Also external awards, we have been successful, so I will not go into all of those details because of time, but we have won several awards in Europe, United States, from our students who participate in the competition. So we're very proud of our students doing all of that. We also won this award we won 3 years in a row actually, so Hong Kong IE Environmental Final Year Project. Our students won that award 3 years in a row. The Smart Fish was one of them, that Grey Water System another one. Okay, so that's a lot about our discipline, student successes. So a few words about the programs, right? So our department hosts 4 programs. So chemical engineering, closely related to chemical and environmental engineering, bioengineering, a relatively new program, and sustainable energy engineering. Okay, so you can find all the information about these programs on our website, so I will not go into all details here, but this gives you an idea of how the structure looks like. So you have your math and science in year 1, introduction courses, and then we have design courses, right? So design is the key skill that engineers are really good at. It's a transferable skill. We have different design courses. Then more fundamental courses, mass and heat transfer. Nowadays data science is very important, so we have a tailor-made data science course in our program. Of course, we also teach soft skills like communication, etc. Then when you move into the final year, right, so you do your laboratory courses, you can do research, and you do a final year project of which we have seen some results. We also have elective courses, so if you have a specific interest in a particular course, you can do that. Closely related chemical and environmental engineering. So it's very similar, as you can see. The main difference is in the electives. So you need to do environmental related elective courses, right? So if you want to go in an environmental type of job, then this is a good program. But it's similar as the chemical engineering program. So it's quite easy to switch actually. Then bioengineering is a very different program. So again, in year 1, you have your general math science courses. This has quite a lot of data science actually. We believe that the modern bioengineer needs to be very good in data. So I think you've seen sensors already, they produce lots of data, but how to extract information from data, right? So we have several data science courses that teaches you those skills for applications in bioengineering, right? So you also learn some biology-related courses, of course, as I mentioned, right? So this discipline is really a bridge between life science and engineering. Then when you go into your final year again, you can do thesis research, or you can do capstone design project. Okay, so if you want more information on these courses, you can of course find me, and everything else is available on our CBE website. Of course, we also support lots of co-curricular activities. Lots of our students go on exchange, right? So before COVID, almost half of our students go on exchange. It's speeding up now again, so we see many students again go on exchange. It's a very nice experience for those interested in that. Internship, research, we organize plant visits, our students go to conferences, and as we have seen, competitions. We also try to organize international internships, so we have an agreement with a company in Japan. They take some of our students to do an internship in Japan for 6 to 8 weeks. So this can be a very nice experience and a good internship. Okay, then to wrap up, a few words about artificial intelligence, right? So we all hear about artificial intelligence. So CBE and artificial intelligence is a very good match. Okay. So lots of our problems that we try to solve related to healthcare, energy, etc., involve lots of data, right? So to extract information using AI is very important. So we do have our own data science courses, so we have data science for molecular engineering, in chemical engineering program, data science for biology and medicine, in bioengineering program, and data science for neuroengineering, also in bioengineering. Plus we have many final year projects that are AI related. Right? So we train students in AI, and we also let students apply that to projects. Right? So many of our faculty have lots of experience in this. So this is an example from Professor Terence Wong. So this was actually in the news quite recently. Some of you may have seen that. So he has developed a different type of microscope and software. So basically this is about discovering cancers from tissue, right? So now the surgeon, if you have surgery and cancer tissue is removed, it may take a long time before the surgeon and the doctor will know whether everything is gone. So in this method, so they designed a new type of microscope based on photoacoustic imaging, and they use machine learning to basically train the software to tell whether the tissue is healthy or not. Okay, so this can help the doctor, right? So the doctor now does not need to make a judgment by him or herself. Actually, the AI will tell whether the tissue is healthy or not. This is a spin-off company now that is actually already going into hospitals in Hong Kong. Another example here also related to bioengineering, so Professor Ji Guang. So this is about cancer evolution. This was also in the news this week. I've seen this on China Morning Post, they had articles on this. So this is a collaborative research, of course, and Professor Wong is doing the data science. So basically they study the evolution of cancer cells, so the mutations, and then they try to understand how to target therapy, right? So how to individualize the therapy for the best intervention, and also to early detect possible formation of cancers, right? So this is a data science, so basically they do genetic analysis of cancer cells, and then they try to recognize patterns, and then they try to inform the doctor what the best possible therapy is to treat the cancer. And this has many publications, and has got a lot of attention. And finally, in chemical engineering, Professor Hanyu Gao. So what he's trying to do is actually, don't tell your chemist friend, but he tried to replace the chemist with a computer. I don't know if any of you is interested in chemistry, but be careful, because he is trying to replace you. So basically, he tries to learn through machine learning, so how to synthesize molecules, right? There's a vast amount of literature on this. Basically, he trains machine learning models that then tells the chemist how he or she should do that. So it's not really replacing the chemist, to be honest, it's more to support the chemist, right? To give good suggestions on how to make molecules from machine learning. Okay, so of course, you want to know the job opportunities, so all our students find jobs. So some go to research postgraduate studies, so some of our students, they go to the top institutes in our discipline, MIT, UC Berkeley, Stanford, etc. So quite a number of our students find PhD positions there. Because of our discipline is very broad, so actually our alumni, they work everywhere. So at 1:30 in this room, we have alumni sharing, so please join if you want to hear where our alumni end up. These are traditional chemical engineering companies like Crown Gas, CBE, but also much broader. So you see chemical companies here, but also environmental consultancy, for example. I love to see you, right? Okay. Please find us outside if you want to further chat on any of this. We will be able to spend most of today. And then I'd like to hand it over to my colleague, Professor Frank, to say something about
Okay, nice to meet you, all of you. My name is Frank Merriman. I'm actually the program director from the Sustainable Energy Engineering. Okay, today let me tell more about the SUSEE. SUSEE actually is a kind of like a new program, okay, since like 2017, 2018. It is a kind of like an interdepartmental program base. So we have like a civil engineering, we have electronic computer engineering, MAE, mechanical aerospace engineering, and also our home department, chemical and biological engineering. Okay, so CBE. So all of that actually we together work with the Energy Institute to work on the sustainable energy engineering. I think all of you actually will have a kind of like thinking about sustainable energy. So is it like related to just only energy? But no, it's actually related to the environment as well. So that's why we actually moved to the discipline. Actually, we have the accreditation because it's kind of a new program, but it's already like 6 years. Okay. So we have the Hong Kong IE accreditation in both disciplines. One is the energy discipline and also the environmental discipline. So I think most of you actually know that energy is a very hot issue now. Okay, starting from Japan actually using the hydrogen as a main fuel in the future. Hong Kong actually has changed a bit actually on the fuel mix, particularly like by 2030. Actually, we have over 50% actually we use the natural gas. Okay. Now, China, actually they have like by 2060, 2030 actually will be the carbon emission actually go to the peak, but by the 2060, actually we need to have the carbon neutral. Of course, Hong Kong also has the very similar situation. By 2050, actually we need to have the carbon neutral. So that's why we have the very high population increase in the future. By the 2050, we actually have like around 8 to 12 billion of the people actually in this planet. So that's why we will have the kind of like an energy need. Okay, if we maintain our lifestyle now, we need like an extra 23 terawatt of the energy actually from the whole planet. So that's why if we just only like depending on the fossil fuels, actually it's not enough. Okay, now UK has already changed from like 7% on the biomass actually to the 14%. Of the biomass now, we actually entertain a lot of the problems like the climate change with the greenhouse effect. So this is the big problem why actually we need to have like set up these kind of the program. We have the energy, talking about the environment, how actually it's closely related. Most of our graduates, not just only from the chemical and environmental engineering, but also we need to pay more attention on the energy part. Okay, so that's why Hong Kong government actually now is they have the kind of like directions. First of all is on the solar. I think every one of you actually have heard about. They have the solar panel actually installing on the roof, okay, to gain some energy, and also the wind turbine that actually is the south part of the Hong Kong, and also the eastern part now is the outside the Hong Kong University. Actually, we have the kind of like a wind field, but they have another one also is on the waste to energy. So these courses actually these program actually we will gather all the information and also the knowledge, particularly on the sustainability, on the environment. Our students actually have a chance to touch with those of the environmental problem, like a wastewater problem, waste gas problem. So how actually they treat with the solid waste. Is it the solid waste just only can go to the landfill? Can they move to the new direction, actually go to the material or fuel, okay? Say like the palm oil now, okay? Palm oil now, they actually use the cooking oil, UCO, and then they start to make it into the biodiesel. Europe actually has a very, I think depending on the a large amount, okay, large demand actually on the biodiesel now. So we also have the energy storage on the battery, okay, like Tesla. I think every day you will see that they have lots of the new car model on those of the electric car. They actually depending on those of the battery. Now it's a very hot topic now for the battery management system, the BMS. So I think most of the students actually they would like to know about more on the battery capacitor, those of the electrochemical reactions. How about the energy generation and also the utilization? Can we do the optimization? Can we actually get some energy actually from the renewable source? This is also one of our concerns for these programs. I know for most of you actually in the high school actually talk about like hydro, solar, wind, wave, geothermal, bioenergy, even a tidal wave. We have like the nuclear plant actually in the Daya Bay, supplying like a 25% of the, we have like a 25% of the power actually from the Daya Bay one, from the nuclear plant. We have, the government actually has a plan actually to move it like a double. to make it 50%, so to entertain our energy increase in demand, actually, for this one. So, all of you actually know that the CLP actually have this kind of what I call the renewable energy feed-in tariff scheme. Okay, if you can get like a 1 kWh actually from the renewable energy, you can get some money actually from the CLP. You can sell this electricity actually to the CLP to get back. Now it's even in Europe, in many of the countries actually they do one thing is how actually they can get those of the renewable energy from the nature, okay, and then they can compensate the high utility fee actually for you. Particularly UK now is a very high price actually on the energy utilization here. So, energy storage. So for the battery one, I think all of you actually know that for the electric car too. Okay, now it's not just only talking about the battery, but also talking about the hydrogen gas. Okay, how actually to store the hydrogen. Not just only the natural gas, and also with the very long time ago, actually we talked about coal, gasoline, those of the high energy content material, now actually shift to change it into the hydrogen because of the environmental problem. So that's why this is I think the main motivation, okay, not just only to our university, but also to the whole Hong Kong, we need to change, okay, those kind of from the how to correlate those of the environment and also the energy usage part. Okay. So that's our objectives of the SUSEE program. We would like to develop leaders. Okay, we would like to develop the professionals doing on the energy system. Now, energy system is a very broad term. Okay, we are talking about electrical energy, but we also have how they're moving from the chemical to the energy one. Okay, how the chemical energy or mechanical one, how they do integration. So that's why we need to have 4 departments together. Not just only the CBE, but also with the civil engineering, MAE, and also EC on those of the electronic circuits, energy usage, but how on the waste to fuel, waste to materials. This is also one of the very big topics in the decarbonization technologies. Okay, we would like to provide a very strong, we would like to provide a very strong multidisciplinary curriculum, particularly on the energy generation, delivery, conversion, storage, and also the efficiency. Now, because this one actually is a hot topic too in the research field. Now, we have my colleague actually is working on the battery one, okay, on the energy storage, conversion, hydrogen fuel cell. I think if you have time, actually, you can visit our lab because we have those of the facilities talking about the fuel cell, how to make the battery, okay, and also very rare in Hong Kong, particularly on the geothermal one, okay. Hong Kong government actually has one of the facilities in the Tai Tak, okay. They actually to do with the one thing is on the central district cooling system. So district cooling system is talking about how to do with the heat exchanger, heat exchange theory, okay, applied actually in the city level. So that's why in this SUSEE program, the unique feature is how actually we combine those of the both traditional one, the one actually we talk about with the solar, also the wind, but also on the renewable one, okay, how to deliver those of the a waste to fuel, okay, waste to fuel philosophy, WTE, but you have the engineering discipline, not just only on the chemical, environmental, but also on the material design, on the mechanical, particularly on the prototype. I think Richard actually has mentioned one thing. On the prototype development, our UG students actually have lots of the opportunities, particularly on the experiential learning, on the experimental setup. Say something like, if you have the idea, actually you can do the experiment by yourself. The department actually will support to do this kind of a research basis. If you have the very new idea and then you would like to develop your own thing, then we actually can support this. Okay. So our engineering lab course, okay, particularly on the lab course now, we have several modules. Okay, I will later talk about that. This one is the study plan. Normally we have a very general science subject, mathematics, chemistry, and also the physics. Even you didn't have this kind of the major in your high school one, you still actually have the basic training on the year one. Okay, and also for the second for the second year, actually you will move to the energy core, particularly on the materials for the energy technology, how to design the kind of the process for the energy conversion, electrical energy, and also the thermodynamics, fluid mechanics, and also heat and mass transfer. That actually is the main area, okay? On the heat exchange, process, principles. Those actually are the required knowledge actually for the SUSEE program, okay? Now move to the final year, you will have a chance to have the working on the FIP, final year project. This final year project, it can be group in group, and also it can be individual. So you can be like just one-man band to do this kind of the project, following a professor actually to do the kind of academic research. But you actually can do with the energy storage, talking about generation, utilization, and also sustainability. Now, I think some of you actually will concern one more thing is around ESG, okay, and also to talk about the carbon credits. So these sustainability part, actually we have some of the carbon footprint study, environmental impact assessment as well. Actually we will include it for the energy environment element actually in these programs. Okay, so currently we have those of the units, okay, current units. So this is for the lab because most of the alumni actually they are very fancy. Particularly they love a lot actually for our lab module. Okay, so talking about we have the being part. We have the wing, okay, pyrolysis, waste to fuel, how actually to change those of we have the coffee ground from the Starbucks, okay, how to change those of the coffee ground into the oil. Actually, we can make this, okay, even from the rubbish to the oil to the fuel, okay, T-waste to the fuel, actually you can do this. We have the fuel cell assembly solar power unit. This is the solar power unit, okay. This is the actually newly purchased from the last 2 years, okay. So we have the glove box for the battery because when you make the battery, you cannot touch with those of the air and also the water because once you touch it, then it will have the chance actually to get fire. Okay, so we plan to have the other kinds like a unit with the geothermal power, steam engine on, and also with the fuel cell electric car assembly because now electric car is actually getting more important. Okay, so that's why we purchase this. Okay. This is the unit actually we will purchase next year. Okay, this is for the geothermal unit. Okay, this is very similar actually to the house, apartment, this kind of things. Now, I think we have lots of the potential employers. We have several batches of the alumni already working in the commercial part, like a CLP, MSD, Hong Kong China Gas, okay, even the Tesla, Schneider Electric, Arab, okay. So we have some of the plumbers. So don't worry about the employment, okay. You see also when you go outside, I think most of the student actually most of the employers actually will say, hey, where you're from? What you're from? USD, CU, and Hong Kong. So no problems actually for those of the engineers. Now, energy discipline with the engineering actually based on the fundamentals, how to solve the problems in hand. Actually, I think we are the only one actually we can do this. Okay, so we're actually working with the Energy Institute. Energy Institute, we have lots of the a very high talent, particularly on the research group. Okay, many very famous professors actually came to the talk, and also to have a very new kind of the energy can be introduced to the UG and also to the PG students. Okay, so do find me if you have any questions. So you can see my email and also my phone number. You can approach me as well, okay, from my office. So if you have any questions, please let me know. Okay. So thank you very much.